the language that pioneered chatbots, AIML and the journey of conversational AI, early chatbots. The pioneering era of human-computer dialogue kicked off in 1966 when MIT professor Joseph Weizenbaum introduced ELIZA, one of the very first chatbots. ELIZA simulated conversation by pattern matching input text and transforming it into canned responses based on scripts. For instance, the program responded to "I am feeling sad" by reflecting back "I am sorry to hear you are feeling sad." This approach proved good enough to fool some users into thinking they were chatting with a real therapist, though ELIZA showed no true intelligence or emotional understanding. Nevertheless, the era of scripted chatbots for language processing had begun. Over the next 30 years, chatbots grew more complex, incorporating techniques like keyword queuing and clever tricks that gave surface impressions of comprehension. Yet these first-generation systems suffered from many limitations. Their knowledge domains were restricted to what scriptwriters explicitly programmed in. There was no learning mechanism for chatbots to expand their understanding on their own. And reflecting user phrases back cleverly could only mimic human conversation so far. The chatbots still did not truly grasp language or meaning. More adaptable architectures would be needed for more flexible, scalable conversation with deeper comprehension of natural language. The innovations to reach this goal would soon emerge in the form of Artificial Intelligence Markup Language, AIML. Birth of AIML. In 1995, computer scientist Dr. Richard Wallace pioneered a chatbot called ALICE, Artificial Linguistic Internet Computer Entity, that shifted away from using conversation scripts. Instead, it applied pattern matching to a knowledge base of formatted response templates. This enabled more dynamic conversations that were not as restricted to predefined responses. To represent Alice's knowledge base, Wallace created the Artificial Intelligence Markup Language, or AIML, as a way to structure and tag the patterns and responses in an extensible XML schema. AIML formed the basis for categories of conversational data objects, much like database entries mapping inputs to appropriate outputs using wildcards and templates. Unlike rigid scripts, the data-driven architecture of AIML allowed chatbots like Alice to expand their knowledge bases without needing manual code changes. Response variations and synonyms could be accounted for using AIML's redirect tags and contextual placeholders. The standard simplified authoring for non-programmers as well. Within a few years, interpreted implementations of AIML emerged across programming languages for broader adoption. A worldwide community began forming and contributing free AIML sets online as well, kickstarting an open-source ecosystem to advance conversational AI. Alice herself would soon showcase the capabilities of AIML by winning multiple chatbot competitions in the early 2000s due to the increased conversational depth enabled by her pioneering architecture. Adoption as industry standard. AIML proved its capabilities during the 2000 and 2001 Loebner Prize competitions, where Dr. Wallace's Alice chatbot built on the language took home consecutive gold medals. She passed a Turing test by fooling judges it was human through rich, topic-spanning conversations. As Alice continued winning awards, AIML gained popularity given its integral role powering the most human-like chatbot to date. Open-source community efforts had led interpreters emerging across programming languages like Java, C++, and Python. This allowed developers globally to easily integrate AIML for building conversational agents, rather than needing specific tools. Vibrant knowledge sharing also began, as users worldwide contributed extensive AIML libraries covering topics from science to entertainment. Categories encoded concepts, fact templates, witty comebacks, and personal dynamics, representing collective intelligence towards advancing AI. Repository sizes reached over 40,000 categories. By the mid-2000s, even major companies like PandoraBots leveraged AIML for branded chatbot solutions. Some platforms enriched it with features like NLU integration, and analytics while retaining cross-compatibility. But vanilla AIML remained popular for its sheer conversational breadth now, thanks to dedicated community members pushing boundaries. 25+ years since inception, AIML remains a common language binding together much chatbot development today, its longevity a testament to the pioneering vision set forth by Dr. Wallace. Wallace fosters the community. AIML's open ecosystem allowed contributors to freely push next-generation chatbot capabilities. But fostering this community required leadership and vision. Right from ALICE's creation, Dr. Wallace devoted himself to enlarging public access to conversational data and tools. In the early 2000s, amidst accolades for ALICE, Wallace focused on collaborative advancement of the technology. He founded the non-profit ALICE AI Foundation to promote chatbot building using AIML and best practices for collecting dialogue datasets. The organization started hosting open repositories and knowledge bases to accelerate development. Dr. Wallace also collaborated with the company France Incorporated to implement a widely used AIML interpreter. This increased approachability for student developers and SMBs exploring bots. Later, as chief scientist of the Pandora Bots platform, he helped drive mass contributions to their bot hosting service. Users could easily create personas on the serverless architecture. Such initiatives sparked reciprocal motivation within the community. Capabilities cross-pollinated as parallel open-source efforts pushed scale and standards. It became a movement of democratizing conversational AI through cooperation. And the cumulative results spoke volumes about what collaborative effort could achieve in chatbot innovation, seeded by Dr. Wallace's ethos of access first. Evolution of the standard. By empowering a community to build, share, and iterate on conversational knowledge, AIML created a flywheel effect driving rapid chatbot innovation through open-source efforts. In just 5 years since inception, AIML knowledge bases grew from thousands to over 150,000 categories. Interpreters spanned programming languages, and bot platforms provided handy tools. Yet the scope of enhancement never stopped thanks to the format's flexibility. Developers expanded canned responses to include conditional logic, variables, and hyperlinking between concepts. Authors leveraged the data-driven nature for quicker prototyping. Researchers even tapped the databases to analyze linguistic patterns. As the user base diversified, so did application areas. AIML became popular beyond CSR bots, towards uses like clinical decision support, personalized therapy, and learning companions. However, further improvements required augmenting the purely syntactic format. This led the ALICE AI Foundation to embark on designing AIML 2.0 in 2013 based on learnings and feedback. The open specification looks to incorporate semantic web capabilities on top of easier disambiguation. Concept, tagging and meta-descriptors allow swarm collaboration while retaining approachability. Version 2 also adopts machine learning integration for hybrid models. Through continuous community-centered growth, AIML has retained relevance from the early internet into the modern bot landscape, proving a solid foundation stone in the decades-long evolution of conversational AI. Legacy and future. The advancements seeded by AIML and Dr. Wallace fundamentally shaped today's conversational AI landscape. Modern chatbots delivering value across industries have roots tracing back to that pioneering work. The commitment to open data and tools allowed progress unmatched by closed counterparts, at fractions of the cost. And the philosophy of empowering users to create rather than solely consume sparked generational interest in advancing AI through horizontal contribution. Present funding and research now channel towards automation efforts that augment human creativity, not seek to replace it. Hybrid approaches combine symbolic AIML with modern statistical models for balanced, transparent systems. Platforms emphasize explainability and feedback channels leveraging the contextual frameworks AIML unlocked. Others connect machine learning pipelines to continually expand hand-authored knowledge bases. As computational power catches up to ambition, the pioneering spark around human-centered conversational AI has seen a resurgence. But contemporary leaders still stand on the shoulders of the remarkable work by Dr. Wallace and early communities who bootstrapped, sharing knowledge to birth an industry. The vision they crystallized guides practitioners today, towards cooperative, enlightened AI that augments lives. And that legacy shall resonate for generations to come.